you hear me say it time and time again that I'm not a big fan of General Motors, and so you might be wondering, why is Thomas Bobergen not a fan of General Motors when Thomas Bobergen owns a vehicle that is made by General Motors? Well, today I'm going to talk about that. Now, in order to begin, I need to specify that I am not a fan of modern General Motors. I am a fan of the old General Motors, which is my generation when they still made decent vehicles. Now, I will say this. Some of the newer vehicles can be decent depending on what your market is, because some of the cheaper lower end vehicles, such as like the Chevy Bolt, or maybe it's called the Chevy Volt now, they changed the name, I don't know. Either way, it's a hybrid vehicle that General Motors makes in hybrid, and General Motors generally, when I put two and two together, I would say, oh, that's a pile of shit. And you're kind of right, because they generally don't last more than about 100,000 miles, but if you're only paying about $17,000 for a vehicle, you're not expecting much from it anyway, aren't you? So that's kind of good in that case. But yeah, so my biggest beef with General Motors today is, their biggest market, which is generally pickup trucks and SUVs, or vans, whatever you want to call it. Just call it an SUV. Way back in my generation, my Silverado / my old Sierra, we had these bulletproof motors called the LS motor. They were from the Vortex series, and these motors ran for 20 years at least. Started in the 90s, I think late 80s actually is when Vortex started, and they just kept improving upon it. Obviously, eventually we went from using carburetors to using spark plugs and fuel injection, port fuel injection. So I guess that's one evolution of it, and obviously there was some tuning done along the way, and obviously more and more horsepower was gotten out of it. I mean, for example, in my generation, the 5.3 got 20 extra horsepower by the time that it was in its final model. There were like 3 different models of the LS during the 99 to 2006 generation of Silverados and Sierras, and the first one had like 275 horsepower. The second LS had like 275. No, second one, or maybe it was 275 for the first one, 285 for the second, and then the final one, which is the motor I now have in my 2004, has 295. So I mean, even just through those few years, they made some tunes and they gave it some more horsepower, and you'd be surprised at the small things you can change in an engine to get a little more horsepower out of it. So it makes sense to me. Anyway, back in this generation, we had bulletproof engines. We had bulletproof transmissions. You can read anything about this online. You can read how these cars went 300, 400,000 miles, original transmissions, original engines. The only thing that'll rot out is the body. And guess you can say that's General Motors' fault, because there are other companies from that time that didn't rust as bad. So, I've read some bad things about the wax coating that they put on the frames. They still use the same wax coating to this day. I just watched a video about it the other day with a 2020 GMC Sierra. Uses the same wax on the frame that my frame had, that I cleaned off. So, whatever. Frame and a frame is a frame, and a body's a body. Now, the frames on these generally didn't get too bad. It was more the bodies that rotted out, but I don't know, to some extent you can't really blame them for that, especially up here when we live in the salt belt up here in the north. Fortunately, salt on the road kind of kills any kind of metal, so can't really blame that on General Motors. If you live down south, your General Motors vehicle generally probably has no rust at all. Maybe a tiny bit of surface rust underneath. Your body's probably in pristine shape in most cases, so can't blame General Motors on that one. But you get to the modern day General Motors, and that's where it starts to become a problem. Now, 2007 marked the first year that they started running this new system called active fuel management in the LS motors. So essentially, they took the Vortex, basically took the same motors, and they slapped on variable valve timing and cylinder deactivation. Now, I say slapped on, obviously it's a little more complicated than that, but essentially variable valve timing. I did a video on that. You want to watch the video about Hyundai and their continuous variable valve timing. Pretty similar concept to that, except it's not continuous. It's more just there's basically, I don't know, I'll say 2 modes, right? Say there's 2 modes. Say there's a low RPM mode and a high RPM mode. The valves will open and close faster, slower, depending on what RPM you're at. And it's electronically controlled. Camshaft position sensor. That's what it does. Most common thing to go wrong on those, by the way. Very common problem on those early Ecotech motors. So they took the Vortex, and like I just said, they changed them to Ecotech. They're no longer Vortec, and we're now in the 3rd generation of Ecotech, starting this year, I believe. So, I mean, we're there. So the idea was get better gas mileage. Now, the variable valve timing was more to get more horsepower out of these because, like I said, it's basically the same motor as what I have in my trucks, but they bumped it up like 30 horsepower, which is pretty significant. And the variable valve timing is most likely the main reason why they got that, because variable valve timing can allow you more, I don't know, say air, right? Your intake and exhaust stroke, get more air in for that combustion, create higher compression. It's basically kind of like an artificial turbocharger, because it's really not. Just a general concept to think that. Just think about it like this. The valve can open and close. If it opens and closes faster, means the combustion process is happening more efficiently. Opens and closes slower means it's happening less efficiently. If it's opening and closing faster, more power. So that's that. Cylinder deactivation. Why is that an issue? You'd think that cylinder deactivation would make your engine wear out less because okay. So in this case with General Motors, half the cylinders would deactivate. That's the way it used to be. So you'd say like, oh, well, you know, the engine should wear less, right? It shouldn't wear out as fast because only 4 cylinders are running. And you'd be right. Except for there's one fatal flaw with cylinder deactivation, and that is that, unfortunately, they found later on that when the certain cylinders deactivate, they actually, oil will still pass into that cylinder, or the valve, I should say. It's a hydraulic system, and essentially a lifter will collapse. Instead of the lifter moving up and down, it will collapse in place, and then it blocks oil flow. But oil still gets into the cylinder, even when the engine isn't spinning those pistons, because the active fuel management electronic system told the engine to stop those specific 4 cylinders. So oil gets in there. The oil is still flowing in there. The engine is really hot, because you know the engine's really hot. So the oil just keeps building up in these cylinder chambers, and then eventually it starts crudding up into carbon, and then it ruins these cylinder heads. And this is what was wrong with active fuel management. This is why it was a problem. So, very common problem. Lifters would fail. Hydraulic lifters, like I said, the lifters would determine whether or not these cylinders were activating or deactivating, and sometimes when the lifters would collapse to start cylinder deactivation, they would get stuck collapsed, or they'd get damaged in the process of opening and closing or getting stuck so many times, because lifters are not designed to just stop. So that's why active fuel management was originally a failure starting in 2007. We move our way on to the modern day. Around 2010/11, they changed the valve cover gasket, and essentially it would collect some of the excess oil that would be coming out during cylinder deactivation and block it from getting into the combustion chamber, or actually more I'd say more the cylinder head, and would essentially stop this carbon buildup, or would stop some of the carbon buildup. And it did significantly reduce the amount of issues concerned with active fuel management, but it still did not completely fix the problem. Because, like I said, it's just fundamentally flawed from the beginning, and the engineers know this. So, did a little bit better towards the later end of that generation, but then we moved to 2014. 2014, General Motors did a pretty interesting thing. No longer was it called Vortec at all. Pretty sure it was still called Vortec from 2007 to 13. It was now called Ecotech in its first generation. And so what they did was they kept active fuel management, kept the cylinder deactivation, kept the variable valve timing. But now, on top of variable valve timing and cylinder deactivation, they now added gasoline direct injection. And this was basically what most automakers are doing this now. And I'll do a video on gasoline direct injection eventually. But essentially, what gasoline direct injection is port fuel injection, which I mentioned earlier, is when the fuel from your fuel injectors is sprayed into the intake on the cylinder head. So say in the combustion chamber, say this is your intake hole and this is your exhaust hole. On the intake hole, the fuel injector would be spraying here, like into this hole in the actual intake, not in the cylinder head. So the air rushes in, the fuel gets sprayed, the air moves the fuel to the combustion chamber, and then the combustion happens. The piston moves up and down. Direct injection is different. Direct injection is when instead of the fuel injector spitting here, fuel injector spits directly into the combustion chamber, so the air just comes right through, and all the gas is concentrated right here, so it atomizes better, and it creates a bigger explosion, creates higher compression, creates more horsepower and torque. So it's a great idea, but this is also fundamentally flawed, and we've learned this over the years, because when you don't have port fuel injection, what happens is because there's no longer gasoline being sprayed in here to clean this intake valve, because gasoline is a natural cleaner, it's basically alcohol, this will carbon up. The intake will carbon up, and then it doesn't allow for proper airflow, and then eventually your engine will start running poorly because the air won't come in the right way through the intake, and then it will start to damage the engine because the engine won't be running right because it's not getting the right air. Modern companies like Toyota are finding solutions to this. Toyota has multi-point fuel injection now, where it injects fuel here to clean the intake valve, but it also does direct injection to also give it the extra power that you'd get from the better atomization of a direct fuel spray right into the combustion chamber. So we're figuring out ways around this, but General Motors isn't quite there yet. Again, so you see the fundamental flaws with that. Intakes get carboned up, and eventually the engine will start running poorly, and eventually it will start doing damage to the engine. It's just common sense. But that's not the only problem. This is just, so basically what I just told you, I said up to 2014. This can basically cover up to 2020 now, because the Ecotech motors haven't really changed much. They've pulled a little more horsepower and torque out of them over the years. Same thing, like I said, basically with my generation of the LS motor, where they bumped like 20 extra horsepower out of it by the end of the generation. Basically the same thing with the Ecotech version 3. Yeah, there's 3 generations, but essentially it's just minor improvements in horsepower and torque, so not really much to say about the differences in those. The other main concern is automatic transmissions. Starting in 2009, was it 2009 or 2010, General Motors started producing the 6L80E in mass production on GMC Sierras and Chevy Silverados, as well as other SUVs such as the Chevy Tahoe, GMC Yukon, Chevy Suburban, all those things, right? 6-speed automatic transmission. This was the predecessor to, this is what came after the 4L60E, which is the transmission that I have in my truck. It's the 4-speed. Well, basically the 6L80E was a 4L60E with 2 extra gears added. So essentially this is the difference. It had the same highest gear ratio in overdrive, but instead of overdrive being 1 gear, overdrive was split into 2 gears. So 5th and 6th gear were overdrive, and then there were just 4 regular gears before that. So it was smoother shifting and better gas mileage in general, because you didn't have to stay at as high RPMs between shifts and stuff like that, and just a more comfortable experience in general. But General Motors produced the torque converters the wrong way. I did a video on torque converters. You can watch that. But if I had to describe a torque converter to you in one sense, it would be a friction plate, where one end's coming from the engine and the other end is connected to the transmission, and essentially when you're stopped, the friction plate is just spinning, and the engine is spinning, but the torque converter is not. So this is the engine, my hand moving, spinning, and the torque converter is not. When you take the foot off the brake and you let the rear wheels have ability to move, the torque converter will start spinning on the transmission, and then they'll start spinning in sync with the engine. So the engine is now spinning the torque converter at the same RPM. That's what a torque converter does. So it's friction, right? I told you that. Well, what comes with friction? Heat. General Motors, from what I've been reading, the general consensus of what the problem was the transmission fluid was not properly designed for these new torque converters in these 6-speed transmissions. and they would burn out really fast because there would be too much friction and too much heat, and the torque converters would just rub out too much. All the friction would be gone, and then your transmission's basically fucked then, because once you have no fluid friction, your car's just not going to move. Now, this was in addition to some other problems. I watched a lot of videos on rebuilding automatic transmissions, and I've definitely watched quite a few rebuilding 6L80Es, and the reverse drum, I know you don't know what that means, but there's drums in transmissions, and they're basically just like these giant, like, I guess I'd call them cylinders that just like contain like gears. They're just the gear ratios, and they're kind of like stacked one in front of the other inside, right? And it's like when you shift from one moves forward to the other, and then just like consecutively like that. So there's a reverse drum, which is, you know, it's its own thing. And there's a whole thing to going into reverse, because you got to go from like the input shaft to then like sun gear gets spun, and then like an orbital gear gets spun, and then when the orbital gear gets spun, it spins in a different direction, and then that's what creates reverse. So it's a whole thing, but essentially there's a giant ass drum, right? And in order for the drum to work, something's got to like push on it. Like a valve has to open and close and push on it. And basically they built these drums wrong, and they weren't strong enough, so that when that thing pushed on it, a hole would be made in the metal, or the metal would warp, and there would be a little leak in it, and then the fluid would leak through it, and then reverse wouldn't activate because fluid would be leaking through the gear and essentially not creating pressure to hold the clutch in place, to hold that drum in place to give you reverse. So these would go out a lot too, because they built the drums poorly. So that's the 6L80E. And you might be thinking like, well, Thomas, that was in 2009. It's 2020 now, so you would think that they fixed these problems by now. No. They are still using the 6L80E in trucks to this day. You can buy a modern day Chevy Colorado or what the hell is the GMC version? GMC Canyon. And they still use the 6L80E. There are still sedan SUVs from GM that use the 6L80E. I'm pretty sure it's still the baseline transmission for 1500 trucks too. I could be wrong. Fast forward to 2000. I don't know if it was 2014, but it was in the 2014 to 16 generation. They added an 8-speed transmission, also made by American General Motors. And the 8-speed had essentially the same issues I just told you about the 6L80E, except now it had 2 extra gears, which led to more problems, because the more gears you have, the more places for things to wear out and fail. And the 8-speed transmission was a failure, and I'll just leave it at that, because it's basically fails for the same reasons that the 6L80E does, except it's even exaggerated worse because it has more gears. Now, 2016. Ford and General Motors partnered to create the 10-speed automatic transmission. I'm pretty sure it's called the 10L80E. I think that's its name. Anyway, it's got 10 gears. And when you have that many gears, you know there's probably going to be problems, right? Especially if it's like a brand new product. And you'd be right. I can't tell you all the concerns and problems with these because they've only been out for a few years, and in mass production only probably about 2 years. But I can tell you this. I can tell you that there have been multiple reports that from websites that I've read of people who review cars and just people who put up complaints about cars that these 10-speed transmissions are failing already, and the vehicle might only be 1 or 2 years old, and gears are dropping one and right. You might lose second gear, you might lose sixth gear, just randomly just lose a gear. And it's like, oh, okay, so you would have thought that maybe they, you know, 2 companies working together, Ford and General Motors. Ford's a pretty good company for the most part. With some of their stuff. So you'd think like, oh, well, 2 and 2 going together. Ford's generally a better company than General Motors in modern years. Maybe they could put something together. That would be nice. But no, they can't. So now we're here with 10-speed transmissions failing after 2 years of owning the vehicle. Not to mention poor quality control. Remember how I told you about the valve springs that were failing in General Motors vehicles? Oh yes, all 2019 to 2020 models of GMC Sierras, Silverados, Yukons, Tahoes, anything with a V8 engine from General Motors. They built incorrect valve springs so that the valves would collapse or they would stop working properly, and then the engine would just blow a head gasket because too much pressure would build and you would lose your engine. And General Motors is now doing a recall on these. Thank God they're at least doing a recall and acknowledging that it's a problem. But it was just saying, you know, they built a valve spring incorrectly. And, you know, it's been how many years since General Motors has been out and they can't correct a fucking valve spring? just things like that. We got that. Oh, the Duramax diesel. The 3-liter straight 6 Duramax diesel. I talked about this on my Snapchat story the other day. If you didn't know, the 3-liter Duramax diesel that's turbocharged, it's got a rubber belt inside the engine to run a high-pressure fuel pump. Now tell me how that's a smart idea. The entire reason we moved away from rubber belts running inside our engines was that timing belts would wear out and break pretty easily. And they just caused problems down the line. And a lot of people didn't really feel like doing the maintenance for them because not everybody feels comfortable opening up the side of their engine, taking off their timing cover and putting on a new belt and then making sure that when you crank the engine that the timing jumps to the right tooth. And people don't want to worry about that. They just want a big solid chain inside the engine that's just never going to break. And that's why we went to timing chains. But unfortunately, General Motors thought, let's go back in the past. Let's not make a chain for this high-pressure fuel pump. Let's put a rubber belt on the high-pressure fuel pump. Oh, and also, let's put it mounted in the back of the engine, right where the transmission is, so that you have to take off the automatic transmission to get to it. And I watched a GM representative talk about this, and the GM representative said this was an easy way to take care of the problem. An easy way? So you're telling me it's easy for me at home to unmount my automatic transmission underneath my vehicle. Keep in mind, it's a 10-speed transmission, so it's a pretty hefty transmission. It's pretty fucking big. You want me to take off my transmission, take off a cover on the back of the engine to access a rubber belt that is inside the engine, keep in mind, that runs a high-pressure fuel pump. Oh, a high-pressure fuel pump sounds kind of important. Sounds like you probably shouldn't have something rubber running it. Sounds like you should have something sturdy, like, maybe a metal fucking chain. Maybe something that's been running engines for years. Now, no. There's not a rubber belt running the timing of the engine. So, yes, General Motors did not cheap out in that sense. But they are cheaping out in the sense that they are asking you to use a rubber belt to run a high-pressure fuel pump, which is something completely essential to running your vehicle. Is it catastrophic if it fails? No. It's not like your pistons are going to hit the valves in an interference engine with a timing belt going wrong, but it's still a pretty fucking big thing if you just get stranded randomly somewhere because your goddamn rubber belt in your modern 2020 vehicle snaps inside your engine because they couldn't design a chain to make the engine last a long time because they don't want you to save money and they don't want you to have a reliable vehicle. And that, ladies and gentlemen, is why I dislike General Motors, specifically the modern General Motors. I hope you enjoyed this 23-minute rant. Thank you.